Welcome to Brain Vision.
Okay, so let's apply the energy balance equation in this case. So we have E dot in is equal to E dot out. If we expand it, we'll have M dot H1 plus Q dot in is equal to M dot H2. So M dot here is the mass flow rate for the water, okay? And H1 is the initial enthalpy, which is the enthalpy at 50 degree Fahrenheit. And Q dot in here is the rate of heat transfer into the system. And H2 here is the final enthalpy, which is the enthalpy at temperature 65 degree Fahrenheit. So now if we do some arrangement here, eventually we have Q dot in is equal to M dot times Cp times T2 minus T1, since H2 minus H1 can be equal to Cp times T2 minus T1. Cp is the specific heat for the water, and T2 is the higher temperature, which is the ambient temperature, and T1, is the exit temperature, okay? And T1 is the inlet temperature, which is the lower temperature, okay? So we know M dot, which is the mass flow rate of the water, is given as 45 pound mass per second. And the specific heat for the water is 1 British thermal units per pound mass times degree Fahrenheit. And we know T2 is 65 degree Fahrenheit, T1 is 50 degree Fahrenheit. So now let's plug in back to the equation to determine the rate of heat transfer, which is equal to 45 pound mass per second times 1 British thermal units per pound mass times degree Fahrenheit, and then times 65 degree Fahrenheit minus 50 degree Fahrenheit, and this will give us the rate of heat transfer is about 675 British thermal units per second. So now let's determine the rate of condensation of the steam, which is M dot 2 here. M dot 2 can be equal to Q dot in over HFG. HFG is the enthalpy of the vaporization of water at 75 degree Fahrenheit. Okay, since in the question you were saying that the heat exchanger at 75 degree Fahrenheit. Okay, so now we know Q dot in, which is the one we just calculated, is given as 675 British thermal units per second. And then at 75 degree Fahrenheit, if you take a look at the table of the saturated water, the enthalpy of the vaporization of the water is 1050.9 British thermal units per pound mass. So now let's plug in back to the equation to determine the mass flow rate for the steam, which is equal to 675 British thermal units per second over 1050.9 British thermal units per pound mass. And this will give us the mass flow rate for the steam is about 0.64 pound mass per second. Okay. And these are the answers for this question.